Hello everybody, this is the lesson 6 of our Python course. In the previous lessons we have learned about classes, and we learned, for example, what instance variables and what class variables are, and we learned about different types of function inside the class. In this lesson we will discuss about inheritance and polymorphism. This lesson will be longer than the previous lesson, but the goal is to cover the whole topic in one lesson. So we first discuss about inheritance, what inheritance is. The constructors and destructors, you are familiar with the constructors and destructors, but we want to see how they behave inside when we have inheritance. We learn how to inherit a method of a class, a method from a class, and we learn how to inherit a class variable or a class of an external library like NumPy and Panda. We learn how to restrict access to our class members. We compare property and getter and setters. We learn about overriding built-in functions, and overriding operators. Actually, you are familiar with the string formatting, but I didn't have time to cover the most important aspects of string formatting for you. So I found this moment a good moment to describe to learn more about string formatting. Then we will learn about a string interface and abstract classes. And the last topic that we will discuss about is polymorphism. So make yourself ready for a long lesson, but I hope it would be interesting for anybody. Actually, these topics are very important. These are good steps towards being a real programmer. So, inheritance. You know, we don't like in programming to repeat ourselves. What does it mean? For example, we write a function and to be able to repeat one functionality multiple times. We just write a piece of code inside a function and we call it multiple times instead of writing that multiple times and copy and duplicating our code in different parts of our program. So this is something that we don't like to do. We don't like to do to repeat ourselves. We don't like to duplicate the code, because if you want to change something in that piece of code, you have to apply that thing to all the different places of your program that you are you copied that piece of program. But if you have, for example, a function and you want to change that function, you just go to that function and change that piece of code, and wherever it will be called, the new version of the function will be called. So this is the thing that is really important to us, to be able to reuse the same piece of code multiple times. Class inheritance is also related to this thing. For example, we already have a class which is implemented for us using an external library, or one of our colleagues has implemented that, or even ourselves implement. We may implement something in the past, and now we want to have a new class with the same functionality plus extra functionalities. So in this case, we go for inheritance. So someone has already done it. Modules such as NumPy and Panda are great for fixed functionalities, but we can add some extra functionality using inheritance and using the classes inside these external libraries. Inheritance is one of the elements of object-oriented programming. Object-oriented programming consists of 3 different aspects. One is encapsulation, the other one inheritance, and the last one is polymorphism. So inheritance is one of them. I will talk about encapsulation during this lesson as well, and also polymorphism. You will learn that in more depth later. So this is our theory, our goal. We should not repeat ourselves. Don't repeat yourself. We should not repeat ourselves. We should reuse our own code. So this is a thing that we should consider in our mind while we are implementing a program. So inheritance is a mechanism by which we can define a new class that gets all the functionality of another class, plus maybe something extra without re-implementing the code. So it is a new class functionality equals to old class functionality plus extra. So we don't want to rewrite this part. We just use inheritance, and we get a new class by having the old class inside our new class. Let's see how we can do this. So the syntax is like this. As you remember, to define a class, we had a class keyword, the name of the class, and a colon. But now, when we want to have an inheritance, we have a parenthesis here, and the name of the base class, or you can call it a parent class, will be here. We can inherit from different classes, from multiple classes, but at least we will have one class if we want to have inheritance. And we have an optional document, and we have the class suite. We have two functions which helps us to detect if class is a subclass of the other class, or if an instance is an instance of an existing class. So let's see how they work. We have each subclass. This is the subclass. This is the superclass or the base class. And it returns true if the given subclass is indeed a subclass of the superclass. So when we have, for example, subclass name here, we write the name here, we write the name of the parent class here, and if subclass is really a child of that parent class, then it will return true. Otherwise, no, it will return false. How about this function? This is instance. This is object, the instance of the class, and this is the parent class. If object is an instance of that class, it will return true. Look at here. This is an example. We have a class employee. It has a class variable. It has a constructor. Inside the constructor, we are creating an instance variable. And we are also checking the salary here. And based on our conditions, we are creating another instance variable here. We have a function give raise, and it will add this amount to salary, which is an instance variable of us. So I can have an employee and work with these abilities, with these functions that we already have. But we can also have another class, which is a manager, and this manager is inheriting from employee. And it has extra functionality, which is display here. So this class will have these function, both of these methods inside this manager. I'm not sure if, I guess you can hear, well, I don't know, but I can hear some reflectance of my voice. I don't know why. Maybe because I should, okay, now maybe it's better. So this manager class, this is a base class, has all the functionalities of the parent class, plus one extra functionality, plus one extra instance method. Here, I'm creating a manager with these arguments, which is calling this constructor name and salary, as you can see. And when I print managed mng.name, it will call this instance variable. So manager is already have all these functionality inside itself. So we have an instance of manager with the abilities, with the functionality from the parents, and plus the functionality from itself. And if I call mng.display, it will call this function and shows us these results. So look at this example. We have a bank account here and we have a saving account. Both of them are different classes. We know that saving account is a bank account. So we should consider in our mind when we are implementing inheritance, we should know that the derived class, we should implement it such that the derived class is a parent class. So what does it mean? It means that wherever I can use the parent class, I should be able to use the child class as well. If you don't consider this in your mind, you may implement inheritance in a wrong way. We will see some example when we can violate this relationship. I mean, we may do it and it is not good, it is not recommended. So we have a class here, it has a constructor, and inside this constructor we have an instance variable. This and the other this class has an instance method, and it's just amount, and it will withdraw this amounts from this balance. We have saving account, and we put here just pass, and pass means that it's just an empty class. But it is not empty. It doesn't have that extra functionality, but it has all the functionality from the bank account. So we are here, we can create an instance of saving account using this constructor. And as you can see, this is the results. And if I print this one, it will gives me, since it calls this one, it will gives me 1,000. If I withdraw the amount, it will do this one using this method. And I can also use this function if this instance, if this object is an instance of bank account, or if this one is an instance of saving account. Both of them will return true, as you can see here, because although we are creating in this instance from the derived class, from the saving account, but it is still a child of this parent class. So it is still an instance of this one. But if I create an instance from the bank account, and if I check this one, I can see that this variable is an instance of bank account, true, but it's not an instance of saving account. So we can also use this method that I just explained to you to check if this class is a subclass of the other one. Saving account is a subclass of bank account, but bank account is not a subclass of saving account, and the result is here. So any place that a bank account could go, for example, as an argument to a function, you will be able to use saving account instead, because it has the same methods and attributes as bank account. But you will see an example that you may sometimes violate this condition, but it's not really recommended. You should not do that. So this is the example that I'm saying that this violates is a relationship. So look at here, this is a bank account, similar to the example that you just saw in the previous slide. And here I'm overriding the constructor of this class. So now this class, the derived class, the saving account, has its own constructor. And this constructor will not be called. So if I now try to create saving account with this command, it will gives me a type error because its constructor now is this one, and this constructor is not reachable from saving account. So from now on, you cannot create a saving account using this constructor. But you know what's the other problem is? The more important problem is, here you are creating instance variables. But since inside here you are using another constructor, you don't have these instance variables as well. So now I create saving account using this constructor, but this constructor is not creating these instance variables for me. So if I try to access balance, it gives me an attribute error because saving account object has no attribute balance. Because we created an instance of saving account using this constructor. If I check if this object is an instance of saving account or is an instance of bank account, it still gives me true for both of the cases. But as you just saw, saving account in fact is not exactly the bank account. It doesn't have the same functionality. It doesn't have all the functionalities that bank account has. It doesn't have all members. It doesn't have the instance variables that bank account has. It doesn't have the self that balance. So this is not good. And the solution is that if you want to have your own constructor in the derived class, you should call this constructor the constructor of the parents inside your constructor here. So if you have to change your constructor in the derived class, you have to call the constructor of the parents class. Based on the language, you don't have to. As you can see, I can write a program without calling the constructor of the parent class. But you are changing the definition of inheritance. You are not really implementing object-oriented programming. The way that you are programming is not really good. You can do many things in programming with a language. Like, for example, when you are learning a language, English language or a Spanish language, any language that you are learning, you can write many sentences, but that sentence may not have any meaning for you. So you should consider, when you are writing something, you should consider that if it is really an inheritance, if it meets all the conditions that's describing some topic, describing an ability, if it is really an inheritance or not. So for this example, you should call, if I need really to implement something extra here, I should call the constructor of the parent class here in the constructor of the derived class. We will see some example later. So derived classes use the base classes as a prototype. Creating an instance of the derived class will not lead to the creation of an instance of the base class. In C++, and I guess in Java as well, if you create an instance of the derived class, it will lead to the creation of an instance of the base class. So there you do not have this problem that automatically the constructor of the parent class will be called. But in Python, it is not like that. In Python, everything is on you. You should be able to control everything. Otherwise, the language itself will not control this for you, because in Python, they consider that it's an adult language. We are all adults. We know that how to write a program. So let's decrease the limitations on writing a program and let the user implement in the best way. And then let the user use the language in the best way. But in other languages, it's not really similar to this. And that's why that you can write your program very fast in Python, but you cannot write it very fast in C++ and other languages, because you should be really worried about all these things. You should really care about that. But most of the programs that you can download, especially the programs that are developed by the researchers in the universities, you may see that they don't care about these things. I'm not talking about all the people, but some people, they really don't care about these things because they just care about their ideas and they want to just implement their ideas fast. So it's something in between. You should not know that. But if you want to be a Python programmer, a real Python programmer, you should consider all this and try to write your program very well. Otherwise, if you want just to write a program, you even don't need this lesson. You can start programming very fast in Python. But these things are important to know if you want to be a real programmer. So the constructor and destructor of the base class will be called for creating and destructing the derived class only if there is not any constructor and destructor for the derived class. As you saw in the first examples, when I didn't override the constructor in the derived class, the constructor of the parent class has been called. But if I override the constructor and destructor of the parent class in the derived class, then they won't be called. So you should call them. To be able to access the instance variables of the base classes, one can call the constructors of the base class where the instance variables are defined in the constructor of the derived class. If you remember in the previous lesson, we said that one of the best practices that we had was to define the instance variables inside the constructors. We said that we can define them in different, in the other instance methods of the class, but we said that it's better to define all the instance variables inside the constructors of the class, because then all the instance variables will be defined when the object is getting created, and we can keep the track of them and we can know where they are. So you can see that the benefits also here. If you define all the instance variable in the constructors in your class, if you are inheriting from that class, inheriting from a functionality from that class, then you only need to call the constructor of that parent class inside your the constructor of your derived class, and all the instance variables will be created for your derived class as well. So these are the best practices you should follow. So let's see some examples here. Don't bother yourself with these different naming conventions here. I will explain them later on in the next slides, in the coming slides. But just look at this. This is an employee. This is a class, and it has some class variables. It has a constructor, and inside that constructor, it has some instance variables. It has destructors as well here. But inside the constructors of this class, I'm printing this message, and inside the destructor of this class, I'm printing this message. I have another class which is inheriting this class, I have also another class. It has, I mean, teacher doesn't have any body. It's, I mean, it only has a documentation, and all the functionality comes from this class. And the driver is another class which is overriding the delete function, which is our destructor, but it's not overriding the constructor. Manager is another class which is overriding both constructors and destructors of the parent class. So if I create an instance from teacher, so the constructor of the teacher will be called. So by this, the constructor will be called and parent constructor. But since teacher didn't override the constructs of the parents, so the constructor of the parents will be called. And here, if I delete teacher, since the number of references to this one reaches zero, so the destructor of this object will be called. So, and as you can see, the destructor will be the destructor of the parent. So here I'm creating an object from driver, and when it is getting created, the constructor of the parent will be called because it's not overriding the constructor. It doesn't have its own constructor, but the destructor, when I call delete on the reference, the destructor of itself will be called the destructor of driver. But for manager, when I create and delete an object from manager, the constructor and destructor of the manager will be called. If you are a C++ programmer, you know that this way is not similar to what you have in C++. In C++, when you create an instance from a derived class, an instance from the parent class will also be created. And when you are deleting them, and the destructor of the parent class and the destructor of the child class will be called. But I'm saying that it's like that, but it's more than this. It has virtual keyboards, some other extras. You should be really careful about them when you are working with them in C++. It doesn't mean that you should not be careful here when you are working with Python, but the way that they are working is different from each other. So note that constructing objects of the child class does not involve constructing an object of the base class, unlike in C++. Method inheritance. So what happens when we have two functions with the same name in one class? As you remember, I showed you one example that if we define two functions with the same name in your global scope, the second definition will be considered and the first definition will be ignored. This is also the case when you define two functions with the same name inside one class. And I said to you, this is similar to function overloading. Look at this. This is a class teacher, sorry. And it has a class named, it has a constructor. It's creating an instance variable. And it has one function, give raise, amount. It's adding that amount to salary. It has another function, amount plus bonus. And it will multiply amount by bonus and call this function. But in fact, when I try to create a teacher here, when I create that, after that, then I try to call give raise, which is this function, as you can see, or we can say that it is this one, it gives me a recursive error. Why? Because this one will not be consider. This one will be eliminated. We have function overloading in other languages, but we don't have it in C++. Even if I remove this one, we don't have it. So every time with this one, if I call this, it will call this one, and inside that, again, it will try to call the same function, and that's why it gives me recursive error, because it's infinitely it's trying to call itself. So it's a recursive error, and it says that maximum recursion depth exceeded. But let's see if we can have such a thing when we have inheritance. So we have a class employee here, similar to the previous. It has a constructor with 2 instance variables. It has a method give raise, adding that, adding salary with amount. We have also a class named manager, and it has another functionality. It has its own constructor, which is calling also the constructor of the parents. So it has name and salary as well as its own instance variables, and it has its another instance variables for itself. Here I'm writing a give raise method, which we already had a give raise method here, and I'm adding another argument to that, and inside that I'm calling the give raise method from the parents with the name of the parents. So now it works. So if I create a manager here, if I call give raise, it will call this one, and inside that it will call give raise, which is this one. So it's similar to overloading 2 functions when we have inheritance. And if I want to call that like this, it will call also this one, and inside that it will call the other one. So you can have similar, a kind of overloading when you have inheritance, but you cannot have it in one class or when you are in the same scope. These are in 2 different scopes. This is in the scope of manager. This one is in the scope of employee. This function. That's why you can have it. So let's see another example. We have an example to see. This example helps us to know how to inherit a class variable from a class. So we have a class player which only has a class variable, and we have a racer which is inheriting that class variable from this class. So here I'm creating an instance from player, an instance from racer, and I'm printing the class variable using player, the name of the class, using the instance from the player, using the racer, the derived class, and using the instance from the derived class. If I print that in this moment, all of them are showing 100 to me, because when I create this is a value for the class variable. So if I change the class variable using the name of the parents to 120, and if I print them, I can see the change using all of these ways. But if I try to change this class variable using the derived class, it will lead to a new class variable for the derived class. As you remember, we had an example that in which I was trying, in the last lesson, I was trying to change a class variable to through an object, an instance of that class. And we saw that if we do that, a new instance variable will be created for that object. And we said that the only way that we have to change any class variable is to use the name of the class defining that class variable. Here it is also shows us the same. So if you want to change this class variable, this is only for this class. Although you can access this class variable using the derived class, but it doesn't mean that you can change that. The only way that you can change it is using the class defining that class variable. So look at this. When I do this one, I can see that the values for the player and P is 120, but for Razor and R is 90, because R is an instance of Razor, and from now on, it's max speed is referring to the new class variable of Razor, and so both are showing 90. And now if I change the max speed using player, it will change only for player.max speed and p.max speed. Inheriting a class of an external library. So you know that you are already familiar, for example, with NumPy. You may also be familiar with Panda, Matplotlib, and the other external libraries. They have some fixed functionalities, but you may want to add some extra functionality to them. So in this case, you can use inheritance. Let's see one example to see how it works. So in Panda, if you are familiar with that, all data frame methods in Panda have many parameters, and it is not sustainable to copy all of them for each method you're customizing. So the trick is to use variable length arguments, this one, asterisk args, and double asterisks keyword arguments to catch all of them. You are already familiar with these two. I have discussed about that in the lesson 4, I guess, when we were talking about how to pass the arguments to a function. So the args was a tuple of the values that we are passing to the function, and this one was the keyword arguments, was a dictionary of keywords arguments of the keywords and the values. So to have inheritance while you are inheriting from external library, it's better to go for these two terms. Let's see how we can do that. From datetime, I'm importing datetime, which is just an example. You can also read yourself about datetime, and we cannot cover that, but it's not really a difficult thing to be discussed here, so you can learn it yourself. I'm importing from Panda PD. I'm importing Panda as PD. You will learn about these things, the way that you can import classes later on in the next lesson. But you already know that you can import a class like this and set a name for that. So I'm creating a new class by getting inheritance, by inheriting this data frame class from Panda class. I'm writing a new constructor for my class, and then the arguments are defined like this. When I'm calling, I told you we need to call the constructor of the parent class. So in this case, I'm passing arg and kw args to the constructor of data frame to be able to create an instance from that. Actually, it's not an instance, to be able to call that constructors. And I'm also creating a new instance variables for my class. So it's similar that it's similar to have a new class, which is exactly data frame, but it has another instance variable that data frame doesn't have. So we are creating a data frame for ourselves, which has also an instance variable named created at, and it has the date that is created. We are writing date time today inside these instance variables. So if you want to add some extra functionalities to the existing classes, to existing existing classes from the inside external libraries, you can go for this way. You can go for inheritance. Now I'm creating an instance of this class, and it's similar to when you are calling it, when you are creating an instance of data frame, because you are passing args and passing them using these two variables. And it has, for example, I can use dot values, which is an instance of a member of a data frame using this, the instance of logdf, and I have also another instance variable, a new functionality for my object. When you call parent methods in the class, they should accept some object as the first argument. As you just saw, it is self here, and it is self here. And that object is usually self, but it doesn't have to be. It is better to be like this, but it depends on your application, on your usage. So with this example, I want to show you don't have to pass every time self to the methods of the parent class. Look at this one. I'm creating logdf, calling the constructor of the data frame, creating a new instance variable for myself, and I'm writing to a new function for my logdf, and inside that I'm getting a copy of the object calling to CSV, and write it in and have a reference to that using temp, and I'm getting the created of that. The creation time of that, and write it to this to a colon of this data frame, and I'm calling to CSV of data frame with this object. Now I'm not passing the self object to this function, to this this method of the parent class. I'm sending the modified version of self to this function. You can do something like this. It might not make sense here with this example, but this is just an example to show you you don't have to pass self every time when you are working with the parent class inside the derived class. Okay, we have learned about inheritance. We learned that how to inherit some functionalities from an existing class. But let's see how we can restrict access when we have inheritance. It's also for, restricting access is also for when you have only one class. So it's not only for inheritance. But I decided to not to talk about that till this moment, because it's something that is better to be talked about when you learned what inheritance is. So if you are working with have experience with other languages, you know that in, for example, in C++ or in Java, we have private, protected, and public. These are some modifiers that you can restrict the access to the member of the classes. In Python, we don't have those modifiers. Instead, we have three different ways to restrict our the access to our class members. Naming conventions, use this decorator, which is property to customize access, overriding getter attributes and setter attributes, which are two built-in functions for your classes. In this lesson, we will learn about, in this course, we will learn about these two ways. You can also do this one, but I think the best way is this one, and also the first one. So the naming conventions. If you want to have a protected member, a protected member in C++ is defined like this. A protected member is a member of the class that can be accessed only inside that class or from the derived class. You cannot access to the protected members from external code, from the outside of the class. So in this case, if you want to define a protected member, some people also call that internal member, you should use a naming convention, which is, so the name of your member should start with an underscore. So nothing is technically preventing you from using them, but it is the developer's way of saying that you should not use them. So the class developer trusts that you will be able to use the class responsibly. So it's the responsibility of the user of the class to use them responsibly. So technically nothing will happen. Technically they are really similar to the public. It's just a naming convention that you are following. And many people are following this naming convention. But they are, I mean, to the interpreter, they are similar to the public. They are exactly like public functions. So as a class user, you should not touch them. As you should consider that you should only work with them inside the class and inside the derived class. You should not read or write them from outside of the class. So what is private members? Private members are the members that have to be actually, that should be used in, okay, let's see first what they are in C++ and what they are in Python. In C++, they can only be accessed inside the class. You cannot access them from outside of the class or from the derived classes. The plan in Python is also was this one, but it is not exactly similar to this. So let's see how they work. If you define a member for your class, either an instance variable or the class variable or instance methods, if you start the name of the class with double underscores, then it will be a private member. The interpreter will change the name of this member to another name. For example, if you have a class whose name is this one, double underscore attribute name. The interpreter will change the name of this one to underscore my class double underscore and the name of the variable. So if you want to access to this private member from the external code, then you have to use this one, this name, the new name. But you should not do this. So in C++, there is not such an extra way to be able to access private. If it is private, it is private. But in Python, it will try to limit the access, but you can still access them using the new name. So it's the interpreter only changed the name. So you cannot access them using their own name. You can access them using the new name, but you should not do that. So we have learned that one leading underscore leads to a protected member. Double leading the underscore will lead to private member. And leading and trailing double underscore are only used for building Python methods like init and delete, which are constructor and destructors. So let's see some examples here. We have employee. This is a public member, public class variable. This is a protected class variable. This is a private class variable. We have our constructor. This is public instance variable. The next one is protected instance variable. The third one is private instance variable. So if I create, this is just a class. There is not any inheritance here. So you are working just with a class. And let's see how we can access them now. We can access the class variable. We said that we can access the class variable through the name of the class. So I'm calling class name, which is a public, without any problem. I'm calling the protected. I said that protected are technically exactly like public members, but these are the way that developer is communicating with you, and it's saying that you should not touch that. It's a protected member. But the language, the interpreter will not do anything special for that. But now I try to access to this private class member, class variable here. It gives me attribute error, and it says that there is not such an attribute for this object. So if I want to access to this private member, I should use the new naming, the new name of that. Employee, which is the name of the class, and the name of the attribute, the name of the class variable. I'm creating an instance of this one. I'm trying to access to the class variables using the instance of the class. It is similar to this one. I can access to the public, to the protected, but I can access to the private one using the real name. I should use the new name for that. If I want to access the instance variables, which can only be accessed through an instance of the class, not through the name of the class, I use even that name to access to the public one and also to the protected one. I can just call them using their name, but I cannot access the private one using the real name. I should use the new name. So in Python, almost any aspects of an object can be reflected and directly accessed by the external code. So as you can see, we are saying that these are actually somehow funny, but this is the way that the Python has been implemented. And the goal was to be an easy language that helps the user to be very fast, to implement its ideas, I mean, his or her ideas and the programs very fast. But when you learn some other languages and you will come here and you will think, you may think with yourself, okay, are we really restricting the access here? What is the restriction here? We can access to all access all of them. There is always a way to access even to the private members. But this is the way that as a programmer you should follow that. The language will not force you, will not bring up some errors for you. This is just some rules that you as a programmer should follow. So as I wrote here, almost any aspects of an object can be reflected and directly accessed by the external code. These promises are in the nature of a gentleman's agreement, which means that while the language doesn't force some promises, it is up to the implementer to ensure that the remaining ones are kept. So it is on you and the user of the class to follow the rules. Otherwise, the language will not force any limitation, any conditions for you. But it doesn't mean that. I mean, many people are following these rules. I mean, if you download some professionally written source code, you will see that they are following these rules. So, and if you want to be a professional, you should follow them. So we had learned how to access and how to have private, public, and protected members in a class and outside of the class. But let's see what will happen when we have inheritance within the base class and within the derived class, how we can access the members. We have the same class variables, we have the same instance variables. We have a destructor here, we have a new instance method. Inside that, I'm calling the public, protected, and private member. So inside this class, I can access to all of them using their name. I don't need to use the new name, the name that interpreter creates for the private members. When I'm inside this class, inside the class that is defining this instance variable. Inside this one, and I have another instance method. Inside that, I'm calling the class variables. A public one, protected one, can be called using the name of the class. But to access to the private class variable, I should use the new name. How about in the derived class? I have a derived class which is derived from employee, so it will have these members. But how can we access them? I'm creating. I have a constructor here, and inside this constructor, I'm calling the constructor of the parent class, so it will create all these instance variables for me as well. And it also has a public instance variables, which is only for manager. It is an extra instance variable. It has an instance method here. If I try to call ID from here, I cannot. I should use the employee ID. You just saw that here ID, since it is defined here, it can be accessed through its name, but inside inside the derived class, you should use the new name for that. This one is not possible. It will give you an attribute error. For the class variables, similar to this one, I need to use the name of the class and also the name of the class that is defining this one. So keep this in your mind that since these class variables are defined here in the parent class, their name is also that one, so you cannot use access them using the name of the derived class. So in summary, we can say that private instance variables can be accessed within the class, but they cannot be accessed from the derived class using their own name. Otherwise, they can be accessed using the new name. Private class member variables cannot be accessed in the base class and the derived class directly, as you can see in these examples. So these are just some commands to call the functions that you just saw, but I explained them in the previous example. You can write them yourself and see the results and see how they work. So here we just talk about the data members, but let's see how we can access to our methods, accessing our methods. We have a class here, which is a base class or a parent class. It has two functions. The first function is public. I didn't give you an example of protected one because as I told you, protected one, technically they won't bring anything special for you. It's just an way that the developer is trying to communicate with you. So I have a public and private member. In the derived class, it's inheriting the base class here. It's calling the constructor of the base class. It has a public function, and it's calling the public function of the parent class. And I also have a private, another public function, which is calling the private function of the parent class indirectly using the name of the base, using the name of the class defining this function. And here I'm calling that using its own name. So when I create an object of the base class, I can call fun here the public function. When I try to use this one, it is impossible because I'm trying to call this one, but the interpreter has changed its name. To call this function, I have to use the new name, but again, it's not recommended. Every time that I'm giving you these ways, I'm also saying that they are not recommended. But you should know that you can access that, because if I don't say these things to you, since they are not recommended, you may find them somewhere later on, and you may think with yourself, okay, I found a new way, I can work with them, and it's very easy. Why Nassan didn't tell this to us? It's very easy we can work with them, but you should know that you should not do that. Even if you can do that, you shouldn't do this. That's why I'm saying that. It's when discussing about them, it's not because I want to teach you these things to use them in the future. It's I'm saying these things, I'm talking about them to let you know that you should not use them. So the derived class here, it's I can call this function, which is calling the public function of the parent class. But if I call this one called private, it cannot be called because it says that the derived class has no attributes of derived fun or even fun. But if I call this one, it will goes correctly, so it has base fun. So we have learned about inheritance and how to restrict access, but let's see how we can do encapsulation, for example. And because we learned that what we should not do when we are restricting access to our members. But we didn't learn how to access the private members from external library. I'm sorry, from external code. This is similar to learn encapsulation, but let's learn more about them. The two things that you can hear about them in many languages are getter and setters. Getter and setters are the methods used in object-oriented programming, which helps to access the private attributes from a class. Setters, these are the methods used in object-oriented programming, which helps to set the value to private attributes in a class. So getter and setters, with getter you can just access to private members, have access to private members, but you cannot change them. With setters, you can change them. You can update the private members. If I want to write a class with an instance variable, private instance variable, and getter and setter in a C++ way, I can write it in Python, but the way is very similar to what we do in C++. Let's see how it is. This is a class. It has a constructor. It has a private instance variable. This is the getter. It's just returning the value inside this private instance variable. And setter is just updating this private member. So now in the external code, after creating an instance from this class, I can access to this member, to this private member, using this public getter function. And I can update this private member using this public setter function. Okay, you may think with yourself, okay, why didn't we make it public here? We could make A here public and work with that directly from outside the class. But the problem is that it's not always like this example. Sometimes you don't want to let the user, you want to share the data inside your private function, private member, private data, but you don't want to let the user of your class change its data. You don't want to let the user change A here in this example. In that case, you only write a getter for your class and you won't write a setter. Or you may want to add some conditions while you are writing a setter or while you are writing a getter. For example, you may here want to add some other value to the setter function. If, for example, you may want to change A while you are writing, this private function, this private instance variable. So when you have some conditions, then it makes sense to have getter and setter. But because of that, because of those situations, we don't let the user to know what is inside our class. We force ourselves to write getter and setters for all the functions when it is necessary to be shared with other them, and use for all the instance variables when it is necessary to be written, and instead of sharing the instance variables directly. So we don't like public instance variables. If they are going to be public, if they are going to be accessed by the external code, you should write getter and setters. But this example is very similar to the way that we write getter and setters in C++ or Java, but in our Java. But let's see how we can implement them in Python. Actually, in fact, Pythonic way is just to write them like a public here. So I have a class here. It has a constructor self A, and you create an instance of that, and you can access to this public member just like that. But it's not really good to do these things. It's against encapsulation, which is a condition of object-oriented programming. So what's the difference between sample class and Pythonic way? Sample class was this one, and Pythonic way is this class. Sample class hides the private attributes and methods. It implements the encapsulation feature of OOPs. Pythonic doesn't hide the data. It doesn't implement any encapsulation feature. You may think with yourself, what is encapsulation? I mean, the common example that usually comes to my mind when I want to explain encapsulation is a refrigerator. Imagine you have actually not imagine, all of you have a refrigerator in your home. So you can use a refrigerator without knowing that how the refrigerator is working, without knowing that what is the technology that it's using, how it works. You don't know. You don't need to know even. So in those cases, what the refrigerator is doing, what the constructor of the refrigerator are doing, is that they only let you to use their product instead of sharing all the things, all the details that are not necessary for you to know. So your classes should also be like that. Your program should also be like that. Wherever you want to share something with other classes, other programs, you should only share the parts that are necessary for the user of your class or your program to know. Otherwise, you should not share them. So this is the meaning of encapsulation. You encapsulate your class, your program, and you will only share the parts that are necessary, that are related to the use of your program. If a person wants to know more, you can write a documentation for your class or your program, and they can learn more about that, like the catalog of the your refrigerator that when you buy them. Or even sometimes you want to share some code with some other people, some programs, but you don't want to let them know that how you implemented that, because they may copy your code, and you don't want to do that. So this is encapsulation. It starts from the level of a function, writing a function, to the classes, to the libraries, and to the products. So you should consider that every time in your mind. So what if you want to have some conditions to set the value of an attribute in the sample class? So in that case, I just told you, so you may think that, okay, why we didn't make it public, that instance variable public. So, but you can see here, I want to have a condition on A, and based on that condition, change this in a private instance variable. So if I don't write it here, then anyone can change it however they want to change. Sorry. So whenever I try to change this one, these conditions will be checked. How to implement the sample class 1, which is this one, using property decorator. This way is really a Pythonic way. I mean, this is really having encapsulation in Python. We can have it, the first way, that sample class in Python, but this is not, I mean, if we do that one, this is similar to write a C++, I mean, we can say that it's similar to translating one code from another language to this language. But it's like when you are, for example, when I'm talking in Persian, if I want to if I translate all the words one by one from Persian to English, you will understand, but it will not be beautiful. So that's why here I'm recommending you, if you want to write getter and setters, don't write them like getter and setter. Try to use property decorator. Let's see how we can do that. Here I have a class, and inside that class I have a public instance variable. But this public instance variable, which we call that it's an property, has its own getter and setter. So I'm with this property decorator with the same name, I'm writing a getter which is only returning the data of that. You can change it to whatever you want, but the common usage is like that. And the setter is the name of that property, that instance variable, dot setter. This is a decorator, and it has some conditions, but it's changing and not a variable, which is a private instance variable. So these properties, A, which names A, is working with an internal, not internal, sorry, it's working with an private instance variable, and the name is the name of this one, the name of the property with double underscores. You don't set this one here, you don't set this private member here, you just set this one, self.a, and it will call these setter functions inside this one. And outside the class, when I create first I will create an instance from property. When I call this one, this function will be called. And when I called this one, this setter will be called. As you can see, this is similar to have a public instance variable, but the user of the class thinks that this is a public instance variable, but in fact it is not. It is a property of your class that is working with an private instance variable. So this is really recommended. This is really similar to the way that you can implement encapsulation for your class, limiting access to your instance variable in Python. And the second way is that you can write two functions, two private functions, getter with this one, get A and set A. It is private function because it has two leading underscores with the same body. Here you are calling this setter method, but at the end you are defining a property and you are using the property function with getter and setter. But again, I'm not, I myself am not a fan of this one because it's a combination of the way that you have in C++ and also in Python. So it's better to me, the first way, I mean this way in the slide 26 is more recommended. Okay, and here, how to ban the user of the class from changing the attributes. So I just told you that sometimes you want to let the user of the class to see the value, but not to be able to change the value of that instance variable. In this case, I'm defining a property A and working with this. It doesn't have a setter So since it doesn't have a setter, I cannot write self.a equals to var because there is not a setter for this property. But I can work with this internal, these private members. So if I want to work with these private members, I just create an instance of this class I call .a. But if I call this one, which tries to change this instance variable, it will return an attribute error because it doesn't have the setter. It says that can't set the attribute because it doesn't have a setter. And the second way when you're going to use the property function is that you write that similar to the previous examples. You write the getter, but you call the property only with the getter. It doesn't have the setter. So these are the ways that you can work with, implement encapsulation, restrict accesses. There are ways let me tell you, you remember that you can add some, you can create instance variables outside the class through the name of the object for that object. But some people may think that, okay, it's really awful why you want to let the user to add some extra things to your classes. But there are some ways to prevent creating new attributes outside the class. But doing so would go against the "we're all adults here" principle. So in Python, the principle that the Python language is following is that it considers that we are all adults here. And so we know that how should work with them. So it means that we consider that if the user of the class adds an instance variable to the class, it knows what he or she knows that what he or she wants to do. And he or she is aware of the drawbacks and the advantages of what he or she is doing. So then we don't limit these things. But if you want to do that, just Google that. In some rare cases, you might also want to write some ways to prevent creating new attributes for your class from outside the class. So we have learned that overloading is not possible in Python, but we can do overriding. I guess you are tired till now because you have learned many things about inheritance and also restricting access. If you are tired, I suggest you now go for a coffee or a tea. Pause the lesson here and then come back and start the other parts. But I didn't want to have two lessons for these two parts because I guess if I upload the other parts in the next week as the next lesson, then you may forget the previous things that I told you. So it's better to have all of them together. But if you're tired, just go for a coffee now and come back and let's continue overriding now. I will continue at. So I hope you are not tired now, and let's continue overriding. You can always override your parent class methods. You just saw that you can override constructors and destructors of the parent class. You also saw that you can add some functionality to the existing functions of a parent class. But let's see how we can do overriding for other functions. You may want a special or different functionality in your subclass. We have class parent. It has a function, an instance function, my method self, and it's just calling parent method. It's just printing a message because it's just an example. It's we have a child class. It's getting inheritance from parents, and also we have it has another function with the same name, with the same parameters, and it's showing a message. So if I create a child class here, an instance from the child class, and if I call my method, it will call the overridden method. It will call this the child method here. In C++, you have many things here. You have, for example, virtual functions and some other things to be able to call. I mean, you can, from the child, call the parent method from the parent child. So it's a bit more difficult than here, but it doesn't mean that you don't have those abilities here. So we can also override built-in functions. Init and del, you are already familiar with that. Reaper, str, cmp, we know that we can recognize built-in function using leading and trailing underscores under name. So, but let's we can also do overriding operators. All the operators has some corresponding building functions like add here, subtracting, and some even equals, greater than, lesser than. So all of these things can be implemented overridden for your class. Let's see some examples. EQ is for equality. Is called when two objects of a class are compared using this operator. Look at this. This is a customer. It has a constructor. It has two instance variables. I'm here overriding EQ here, and with this one, I'm just printing a message and I'm comparing every element, every instance variables of self and other. Other is the other one that is comparing to the self class. So I'm creating two instances for this customer from the customer class. And if I compare them, first it will show this message to me, and since all of the members are similar to each other, it returns true. If we do not override EQ, this command leads to false because it doesn't have this implementation. So if you want your classes to be able to compare to each other, you should override EQ for yourself. So this is another example. In here, when I say, it's because I know some people may get tired and just try to skip some parts. When I say that this is an example, you should consider that I give some lessons through the examples. So don't skip the examples because they are important. So this is the example in which this is a class EQ, and I'm just it's not, it's just an example. It's not really comparing the self and other to each other. Just I wanted to show you which method will be called when we are comparing different instances with each other. So here, this is a parent class, and it has EQ. Here I'm just printing an EQ function, sorry, a message, which says that it is the parent EQ method. I have also here the child class, which is inheriting from parents, and it says it shows a message to me. It is another class. There is not any relationship between my class with these two other classes. So I create three different instances from these three different classes. If I compare P and C, which are two instances from parents and C from the child, if I do this, the child's EQ function will be called. If I compare C and then P, you can see that again the EQ function of the child will be called. But between these class, parent class, and my class, the instance of these two classes, if I compare P and M, the left one will be called first the parents, and again between these two, the EQ function of my class will be called, which is again the left one. So if there is not any inheritance between the instances, any inheritance relationship between the instances, always the EQ function of the left one will be called. But if there is there is a inheritance between these two instances, it always calls the child's EQ function. As I also wrote here, Python always calls the child's EQ method when comparing a child object to a parent object, as you just saw here in this example. We also said that we can override two operators that are important to be overridden is str and ripper. Str is a function that is called when you call print over the instance of your class, or you are trying to convert that object to a str. So for example, for Python, this is a numpy array which is creating, a constructor that is creating a numpy array for you. If I call print, it will show me this message. If I call str, it again show me the same message, because both of them are calling a str method. The message that they show is an informal. This is for end user, and it's just a string representation. But Reaper function is a function that is called when you call Reaper over the object of your class, or when you are trying to print an object in the console without printing, just calling that an object in the console. So if I call Reaper over this one, you can see this is it shows me this message. If I also write this one in the console, it shows me this message. It is formal. It is for the developer. It is a reproducible representation. What does it mean? It means that I'm saying to the developer that if you go for this structure, for this command, you can create this data. You can reproduce this data. But for this one, which is informal, I just show the data. I don't tell the user that how you can reproduce this one. So Reaper is more formal and it's for developer. str is informal and it's for the user. If you do not implement str, it will and you call print or str, then it will call Reaper function, which is implemented. So it is fallback for print. So if you only choose to implement one of them, choose Reaper, because it is also used as a fallback print when str is not defined. Okay, as I said in the beginning of the lesson, I told you that I don't have time to cover, to learn, to teach you much about string objects, formatting string objects. You already learned about string objects actually, but formatting the string objects, we didn't discuss about them a lot. So I found that it's a good moment to talk about them while we are talking about str and Reaper function. So the old way just go for it. I mean, during your programming, you can just go to the Python documentation to learn more about these string formattings. But the most important thing that you should know is these two slides are in these two slides. Old way, you can just write a message inside your double quotation or just a quotation, a single quotation. This is my message, and here I'm saying that an integer will be placed here, and then after that I use the percentage remark, percentage sign, and a parenthesis and the variable referring to that integer object. The new way is to use again double quotation or single quotation. Both of them also can be used for triple quotations that that I taught you, I think, in the first lesson. We will see some example of that in the next slides. In this this new way, you use curly brackets, and in the first phase, a name, which is a keyword, and dot format the name and the name of the variable. So n will be placed here. For this one, I'm using positional arguments, and I'm giving the position of that. This is 0, so I'm saying that the argument 0 in the position, the first argument should be here. And if I don't write anything, the position here will be 0. And if I use another one empty bracket here, the next one will be 1. So it's like this. You can use double quotation marks inside single quotation marks and the way around, but to nest the same set of quotation marks, you need to escape them with a slash like this one. So if you have this one, inside that you can use double quotation. But if you want to write single quotation, you should just write slash one quotation. Let's see some examples. This is my num, this is an integer object. This is a string object. I'm creating a variable, and this is ellipsis. This is similar to pass. It's just comes to instead of a command. Just I wanted to show you how you can define a variable with this structure. If I print that, you can see this value for that. And the old way is that, as you can see here, I'm writing an integer here, string here, writing an integer here, string here. So if I print this one here, you can see that this is old way. My num is 5 and my str is hello. Printf, okay, here I'm using the old way again, but with triple quotation. As you remember, it will lead to, let's see what it shows us. Here I'm saying that my num should be here. With this one, I'm saying that my str should be here. If I print that, as you can see here, my one line, because one line here, my name is 5, and one line here, and so it will exactly show how you wrote your message in your program. You do not need to write /n to have the enter. So this is the way to have /n or /r inside your message. You can use the triple quotations. And the new way, as you can see here, my num is 0 and 1, and I'm giving the arguments in a positional way, as you can see here. And my num is, if I put empty here, it will be 0, and this one will be 1, and my num and my str, and as you can see here. And if you want to have a quotation in your text, because it has double quotation here, I have to use slash quotation. As you can see here, it shows me this one. And for this one, N and S, I'm using keyword arguments. And since I'm using double quotation here, inside that, I can just use this one. I do not need to write a slash. and it shows me this one. But if I want to use double quotation, and again, since I'm using double quotation here, I should use slash. And I can have also these triple quotations with this new way of formatting the text, as you can see here, and it will shows me this message. So how can we use the string formatting with str and reaper? You can see here. So I can override the str function like this and like this one. And as you can see, with str, I'm formatting employee name, the name, which is the name of this employee, and the salary, the name of the salary. I'm also use a /n here to have an inter. But in Reaper, I'm trying to let the user know that how can reproduce this object. So I'm writing the name of the class, which is the way that you can create an object from this class, and the name and the salary and the rest. And if I here create an object from employee, if I just print them one, it will call this str, and it will show me this message, which is the informal, which is a modified version. With this message, you cannot create a new object from employee. You cannot reproduce this object emp1 with this one, but you can again reproduce emp1. You can see that this is similar to what we wrote here. So Reaper is more formal. Okay, till now we have learned about overriding, and the next topic that we are going to discuss about that is interface and abstract classes, and the last one will be polymorphism. So interface and abstract classes. Abstract classes, the definition is very similar to what we have in C++. Any class inheriting from ABS, this is a class, with one or more abstract method becomes an abstract-based class, which means that it cannot be instantiated. Any derived class must define a body for the abstract method, or that derived class will be considered an abstract-based class as well. So the abstract class cannot be instantiated. It's just a class that other classes will get inherited from, will inherit. And they are responsible to override, to implement those abstract methods. They have some abstract methods. But what is interface class? An abstract class that has no member variable and where all the functions are abstract methods. So interface class, it has nothing, and the only thing that it has is abstract methods. Base classes where you have to derive from them and then implement the abstract methods. Where they are useful. For example, interface class, for example, you are sharing a library with other people, and then you don't want to share your own class. You just want to, it's like encapsulation. You don't want to share your how you implemented your code. You just want to share the interface class. So they're one of the usages of interface class. Abstract class, you implemented something, and it can be used with other 3 different classes, for example. So instead of duplicating your code in 3 different classes, you write a parent class, and all of them are getting inherited from that. And you don't want to have an instance from that parent class. The parent class is just an abstract class. It doesn't exist. You don't want to have an instance from that. It's an abstract thing. It cannot be instantiated. In those cases, then you will go also for abstract class. But what is the syntax? The syntax in Python interpreter 3.4 is this one. You import ABC. From ABC, you import ABC, an abstract method. You write a class, and that class can have any name. It doesn't have to be abstract, but it inherits from ABS. It has some methods, at least one method, which has this decorator over that abstract method. In Python 3.0, the syntax is different. You import ABC meta instead of this one, and you inherit from that class like this: meta class equal ABC meta. But the rest is similar. In Python 2, it's also different, as you can see, but this is not our way. Depending on your interpreter, you should go either for this one or this one. For my interpreter, I had to use this way of calling this way of implementing the abstract class. So I import these two from ABC, and I created an abstract class which is human. So human is an abstract class for me. I don't want to get an instance of that, but it has some functionality that other class wants to inherit from. So I'm having a constructor. It has some instance variables, and I'm having instance variable. It's just a normal function. Instance method, just a normal function. It has just one abstract method, which makes it an abstract class. But you can implement this one or not, but even if you define it here, it will be treated as past. So you should not define that, because if you define that, it will not be considered, it will be treated as past. So because the other class are responsible to re-implement this function. So no one, and you will not have also an instance of human. So who will call this int function if you implement it here? So just write past there. I have employee. It's get inherited from human. It has a function lower name, but it didn't implement this abstract method. So this one will be also an abstract function, sorry, an abstract class, because it didn't implement the abstract method. So employee cannot be instantiated as well, like human. Parents and baby, the parent is is a child of human. It's implementing it here. So now this class can be instantiated. We have baby here, and it has it's also implementing this is, so it can be instantiated. If I try to get an instance from human and employee, you can see here it gives me type error, can't instantiate abstract class human, can't instantiate abstract class employee. So these two is not possible because they are abstract classes. And if you want to create an instance from parents, which is mom, it is possible. And if I print that it will print this one. And it's like mom.upper name. You can also call this one without any problem. And also this is the case with baby. So the next topic that we are going to discuss is polymorphism. We said that we have encapsulation, inheritance, and polymorphism as three elements of object-oriented programming. Till now you have learned about encapsulation and also about inheritance. Now we are going to learn about polymorphism. In fact, everything Python is really good for polymorphism. It's already supporting. It's already supporting polymorphism. For example, since you are not writing type of your objects when you are defining a variable, so you can have different variables. For example, you can have a list of different data types. So this is polymorphism. It means that you have different shapes, different shapes just for one. I don't know. Let me explain it using this one. Maybe you get it better, and then I will add some extra explanation. Using a unified interface to operate on objects of different classes. So, for example, you have a list of different objects, or so. For example, in C++, you cannot have such a thing. So this is some polymorphism, and you can you can have a for loop over different objects which are coming from different types. So this is a type, an example of polymorphism that you have in Python, but you can have extra with your classes. But let's see how we can do that. Something that you can consider when you want to implement polymorphism is the scope substitution principle. It says that base class should be interchangeable with any of its subclasses without altering any properties of the program. You remember is a relationship. It's similar to that one. So synthetically, function signature are compatible arguments and return values. So if we have a parent class, in the derived class, when you are overriding a function from the parent class, it should not add more arguments. I mean, in a way that that is not a parent class. It should be always a parent class as well. So that your child class should be always a parent class as well, even if it can have extra functionalities. Semantically, the state of the object and the program remains consistent. Subclass method does not strengthen input conditions. Subclass method does not weaken output conditions. These are the functionalities that we are inheriting from the base class. And no additional exception. So the exception should not be new, because exception will weaken your base class. Because your parent class cannot catch those exceptions. If you define new exceptions, then your child class is not your parent class, because the parent class cannot catch those exceptions. The ultimate rule is that if your class hierarchically violates the least scope substitution principle, then you should not be using inheritance, because it is likely to cause the code to behave in unpredictable ways somewhere down the road. So if it violates this principle, don't go for inheritance. It violates is a relationship. Don't go for that. An example of this violation is a square rectangle problem, or also known as circular ellipse problem. Look at here. I have a class rectangle and I have a class square. The rectangle has a W and H. And it says the constructor will set two instance variable with W and H, and it has a setter for H and setter for W, and all of them, I mean, as you can see, a square class is getting inheritance from rectangle, and it's in the constructor you only have W, and W will be assigned to H and W because it is a square. And the setter function for both of them will be equal. H will be assigned to both of them, and W will be assigned to both of them. You may think that, okay, I have two classes and everything is fine. This one is inheriting from that one, and everything is fine. So, but this is not correct, because you are weakening your setter functions here. For example, you have a unit test. If you are not familiar with unit testing, is a way to test your classes, to test your product. You will define some unit tests for your classes, for your functions, and you expect that all the tests will remain true even if you are changing your program. So, for example, you will write a unit test for your parent class, and that unit test should also be true for your child class, but it is not true if you have such a thing. For example, I wrote, I'm using the unit test from library, and I'm writing a class which is inheriting from that library, and I'm defining a function here, and it's test the rectangle W. In this one, first I create a rectangle object, and I'm setting with 50 and 20, I'm setting the W to 100, and I expect that the rectangle, the age member of, the member named age of this rectangle is remained 20 because I only changed W. So it will be correct because it's a rectangle and it will cost a W from here. But if I create a square, which is the child, and if I set to 100, and if I check this condition for that, and I see that, no, this is not correct. So here you may see that because both of them are created in the same scope, and you may think that, okay, why do you wrote such a test? But in fact, you can call, you can write a test function and call both of them with this one. And let's see later in C++, look at this one. This is the example that you just saw in Python, but this is a pseudocode of C++. It's not exactly C++, but this is the way that you can work with polymorphism and classes in C++. Because this example is given in C++, I thought it's better to also show you a pseudocode C++ with this example. Look at this one. I'm creating an instance of the rectangle class, and I'm putting that in a variable of type of the parent class. And I'm setting the width of that to 100, and I'm checking with this unit test, I'm checking that if the height is 20 or not. Okay, like what you just did here. So it will give me true, and it is okay. But here I'm creating an instance of the child, but I'm putting that into a variable of type of the parent. This is the meaning of polymorphism. Since you do not have this thing for your variables in Python, and all the variables can be assigned together, you cannot see with your eyes that a polymorphism is happening here. But in fact, you have it already. You can have your a variable of type of the parent, but inside that you can have a child because you have reference to all of that. So in this case, for this example, it might be clear for you that I'm creating a child, but I'm putting that inside the parents, and I'm setting the width of that to 100, but this one we call from this, and when I check this one, the height has been changed, and the test will not be true. This test will not be successful. So again, it's a pseudocode because if you are a C++ programmer, you may think that no, here the set width of this one will be called. You know, the rect should be here, rect dot set width. I know this is just a pseudocode to show you how polymorphism is happening. In fact, you have a parent. The child should be a parent, and it should have all the functionalities that parent has. And if you override them, it still should be able to act like parents. Okay, I hope you got what I'm saying, and this is the whole things that I wanted to cover in this lesson. It was really tiring for me. but I hope you're not tired, and I really recommend you to practice a lot. Practicing makes perfect, makes master. So like the people who are saying this for in the gyms, that you should practice a lot, or even in the language courses. This is also the case for learning programming languages. You should practice a lot to be able to learn them. In the next lessons, we will learn about um, probably super classes. We didn't discuss about them, and also exceptions, different modules and scopes and packages. So, but the good thing is that we have covered the most topics related to inheritance classes. I think we have learned a lot, and it was really useful for me, and I hope it is also useful to you. Have a nice day, everybody. If it isn't day, have a nice day, and if it is evening, have a nice evening.